We just finished learning about our biomes. Now we're going to look at primary succession, secondary succession, and such. So these are things that have been on your homework in the past. We're going to dive a little deeper now. So first, we have primary succession. That is the series of changes that occur in an area where there is no soil or organisms existing. So primary is first, okay? So no soil, no organisms. There's absolutely nothing there. We, on our homework, it's given us the example of, having a volcano eruption, right? And it's destroyed everything, but there's nothing there whatsoever. Or rather, a volcano or island is formed. Okay, so there is no soil, nothing there, nothing that that is living in this moment. The first species to populate an area is called a pioneer species. So if you think back maybe to 5th grade, they might have taught you about the pioneers who traveled and adventured out across the continent, right, and discovered these things. They were the first people to be doing so. Okay, so in this case, pioneer is referring to the first as well, but we're talking about the first species to live in an area. And your typical pioneer species are mosses and lichens. As these species grow, they break down rocks and they can help start the formation of soil. After a long time, maybe even centuries, hundreds of years, a community of organisms is established, and it does not change unless the ecosystem is disturbed. Now, if we're looking at this next one, it's going to change gears a little bit. After a forest fire, you would have not primary succession, but secondary succession. The reason for that is because secondary succession refers to a place where things have already been living. Okay, so primary, the very first, non-living. Okay, secondary, you have a place where things are living, but it is still changing. Okay. There are things that happen, natural disturbances that happen in the world, and those things lead to succession. They can be fires, they can be hurricanes, or they can be tornadoes. Secondary succession usually happens faster or more rapidly. Oops, let me stop that. Than primary succession, because there's already soil that exists. It's already established, and an ecosystem has already been in place. So secondary succession is faster because it's already got the soil. It doesn't have to worry about creating the soil. whereas primary succession has no soil, so it takes it a little bit longer to do so. And then adaptations. Help organisms survive a changing ecosystem's new conditions. Okay, so maybe it's, if this ecosystem is consistently changing, if you are going through secondary succession, then certain adaptations in organisms might help them live more successfully. It might be that certain organisms haven't adapted well, so they're going to die out. Okay, if I can find the correct page, I will give you some examples, but I think I'm going the wrong way. Not the right page. I'll come up with those examples though. All right, so maybe we've got a fire happening in a forest, for example. So if we're looking at a certain type of grass, a fire might be burning the blades of that grass, but the roots of that grass are underground. They can be unharmed. So since it has roots underground, it's not being affected by that disaster. It has adapted structurally, or rather physically, and that's going to help it survive. Also, a pine snake is able to escape the fire because it can seek shelter in the burrow of a gopher, for example. That will be an adaptation for its behavior. It has learned to behave in a way that's going to protect itself. Another example, a longleaf pine seedling is topped with a moist tuft of needles. So as the fire might burn those needles, they are producing the steam that they need to move the heat away and extinguish the fire. Then if the needles burn off, the seedling can regrow from its roots. So another example of physical adaptations. There might be some thick scaly bark on some trees, and the fire might burn that, but those flakes fall off and take that heat with them. So the tree has adapted by its bark being kind of scaly, so the inside of the tree is protected. Then maybe a woodpecker is able to fly away from the fire safely. So a behavioral adaptation, because it's learned to behave in a way to save itself. All right. We're going to save this page for Thursday. Let's look at this. Okay, so we have learned that over many years, the process of succession can transform an abandoned field into a forest. Succession can also transform a pond into a forest. How can an aquatic ecosystem change into a land ecosystem? Examine the sequence of changes shown in the figures below, then answer the questions. So we've got 4 images here. Our first one, we've got our pond. We see turtles, we see fish, we see all that water, and of course we do see the trees in the back. Our second one, we're seeing that the grasses and such are growing up, and there's no more turtle. That makes me sad. Our third one, there's very little water, right? It has turned mostly into soil and trees and tall grass. And then in our fourth one, our water has disappeared, and we see all our cute little critters, our deer and our bunny. Okay, so what type of succession might be shown in this? It's going to be secondary succession. And the reason is because we had our ecosystem that is already established in the beginning. Remember, secondary succession has an ecosystem in the beginning that is already established. There's already soil there. There are already things growing there. Okay, so because of that, we have secondary succession. All right, name 2 pond populations that could not survive in a forest ecosystem. Well, I've already mentioned we have our turtle and our fish. Are those going to survive in an ecosystem with no water? Or very little water, rather. No, not really. Okay, so we're going to have turtle and fish. And vice versa. What are 2 forest populations that couldn't survive in a pond ecosystem? Well, we have our rabbit and our deer. We've also got our birds. Okay, so could the deer or the rabbit survive in the pond? No. It needs that water, obviously, but it can't live in it. Okay, so I'm going to write deer and our rabbit. Okay, and then I want you to take a minute to describe how the ecosystem changed from here to here. Okay, now we're on this page. Okay, so we have 2 questions here. Don't want to skip those. What organisms are usually the pioneer species in a new area, and how do those organisms prepare the area for other species? Well, think about what we just took our notes on. So those pioneer species would be mosses and lichens. And they prepare the area for other species because they break down those rocks and begin forming soil. Okay, the illustration below shows succession in an abandoned field. How did the plant populations in the community change over time? Well, the years after the field was abandoned: 1, 2 to 4, 5 to 15, 25, 50 to 150. Okay, so how did the plant population in the community change? Well, it's pretty easy to see that over time, the plants grew, right? We had our small grasses here, and then we had things starting getting taller. We had our trees go from seedlings all the way up to these really tall trees, right? Okay, and notice it took a very long time, right? So that doesn't mean that succession is going to happen overnight, right? It could take a few years, or it could take several years. Okay, now I'd like for you to go ahead and answer those 2 questions there. It says that you're going to identify each of the following as an example of primary succession or secondary succession. So our first one, number 3, is going to be secondary succession. Okay, because we already had soil established. There was already an ecosystem. Although there was a house there, it was something that was there. Like, it wasn't just a brand new situation where there was no soil, right? Okay, so that would be a changing area from one thing to another, which makes it secondary. In our second one, an undersea volcano erupted and formed a small island. Mosses and lichens began to grow on the bare volcanic rock. Well, it formed a small island, and mosses and lichens were there, which reminds me of the notes we took where we said mosses and lichens are pioneer species, meaning they're the first species. So that tells me we have primary succession.